Okay, well thanks, good to see everyone here again. Thanks for the invitation, Al. Great to be at the event. Health warning, I'm a techie, not a presenter, so don't expect the polish of the previous sessions, but I'll do my best. So we're going to talk, a bit of a shift in topic here. We're going to talk specifically about mobile in relation to sort of IoT and enterprise style applications. So, for way of background, and set the scene a little bit, we live in a mobile culture these days. The mobile networks have become sort of the fabric of society in some ways. It underpins so much more than it used to. It's a real fundamental part of the infrastructure that we all depend on. Mobile innovation is typically dependent on two different things, two elements. You've got the platform, which serves a particular vertical or particular need, and then you've got the connectivity to get to that platform. Those platforms often reside in the cloud, and when I talk about cloud here, I mean in sort of a hyperscaler, infrastructure as a service, platform as a service, AWS style. And those platforms are very agile, they're programmable by definition. They've been designed to allow, as a platform, to build things on top of. They're good for developers. They're very observable, they're accessible, they're open, they're democratized. Anyone can use them to whatever scale they need. But the connectivity to those platforms in lots of applications is based on the traditional mobile networks, and that isn't agile. It isn't self-service. It isn't flexible. It's a totally different ethos in the way that those things have been built. So why is that the case? There's some historic reasons, some technical reasons. What can be done to change that perception, and how are we going about it in our project? So the reason for the difference, there's a few differences. The hyperscalers and the cloud providers, they were designed to be platforms. They're designed to be technology which others build on top of. Whereas the mobile networks were designed to provide a service. It's a different start point for the set of requirements. Hyperscalers aren't really burdened with much legacy. The technology has been built over the last couple of decades, layer upon layer, with no real historic constraints. But the mobile networks have got 40 years of legacy. We're on 5G now, and all those other Gs. There's lots of legacy which has been carried forward, and we'll look at that a little bit on the next slide. The hyperscalers have got a lot of architectural freedom. They can build their networks and roll it out as they see fit to meet the needs of the markets and the customers, whereas mobile networks are quite tightly defined. There are norms, there are standards, there are architectures which almost every operator has to use practically, which does constrain what can be open and what has to be closed. The hyperscalers, as I said before, built for innovators, built as a platform. The networks are built really for end users primarily. Cloud is about democratization of control, APIs, automation, orchestration by the users, by the customers, whereas mobile networks are designed to be controlled centrally by the operators. And the interoperability requirements for cloud. A cloud platform sits on the internet. It needs to understand DNS, HTTP, the basic protocols. They're not much more than that. Whereas mobile networks, particularly through roaming, the connectivity, the signaling between those networks has to be very tightly defined. It's become very, very complicated. And each generation of technology makes changes to that, which adds complexity rather than takes it away. And the standards behind the typical internet, if you like, are very much by consensus. The RFP process, the standards have been emerged through the community, whereas mobile networks have to adhere to standards which are essentially regulation defined by GSMA, 3GPP. They've been defined in a quite complex and tight way. So the 40 years of legacy of mobile, I won't go into this in too much detail, but we are on 5G now. We've gone back from the old 1G, if you like, analog 80s style flip phones, which are worth a fortune on eBay now, right through to modern high bandwidth platforms. But there's overlap between these phases technically, so that implies there's a need for backwards compatibility. So when we're over here on this side of the model, this technology still back from 2G, 3G still has to be supported. It's difficult. The services provided to users have changed over that time, and also we've very much changed from what was originally a peer-to-peer calling your friends technology to something which is a lot more M2M and IoT centric. And on the technical side, I won't go through this in detail, but there's almost a blueprint for how to build a mobile operator. There's particular building blocks with their own acronyms, their own standardised interfaces that's evolved with those generational steps. And there's standards for how those platforms talk to the rest of the world, and those are really important. Without those standards, you don't have interoperability, roaming doesn't work. That stuff's really, really important. But in the middle, there's also a lot of standards which are within the network, and the purpose of those standards really are really about procurement efficiency, being able to buy an HSS from Nokia, a packet gateway from Huawei, they all talk together. So these various platforms that you buy from the vendors, they're all quite similar to one another. They're black boxes. They're well understood, but they're not really designed to get inside of. The lids are tightly screwed shut from a developer's perspective. It's very much a north-south integration model built on layers. It's not really historically been a service-oriented architecture. It's difficult to get under the skin of this stuff. It doesn't lend itself to democratized control. There's data duplicated all around this architecture for different purposes, not for different customers. It's functionally distributed. Although it's proved to be a good model up until now, it's all about the operators keeping control. So how does that manifest itself as a developer, the differences between these? So I've taken an example here about a developer who wants to create a virtual private slice of connectivity or private network. And in the cloud world, that might be a VPC. It's a network which you can create very easily. On the mobile networks, that might be an APN, as it's called, which is a private layer 3 connectivity to get your SIMs to your back end. So on the cloud scale, it's 2 o'clock in the morning, we're halfway through our pizza, we decide we need a virtual environment, we log on to the AWS portal, a few clicks, click go. A couple of minutes later, we've got a new VPC, some virtual machines. We start paying monthly a few dollars for that connectivity. It's all under our control. On the mobile side, if you decide you want an APN at 2 o'clock in the morning, well, good luck, because this goes through a very engineering risk management process with quotes, service orders, takes weeks, costs thousands of dollars. So you only do it. It's a very coarse chunk of functionality. You can't do this many times for small applications. This is the typical telco approach, very different from what's in the cloud. So what we're trying to do is how do we take all the flexibility that developers have got used to on the cloud and apply it to mobile networks to give them the same sort of experience. So there's quite a few vendors who've had a go at this. The typical approach is to build sort of a service exposure layer across the top of the core network. Use the APIs, maybe proprietary APIs that these various building blocks expose. Use or abuse some of the signaling protocols which are defined by the standards for other purposes. It's a pretty non-disruptive way to go about it. It's pretty easy. You take the standard network and you're just wrapping it up. But it does mean that the actual functionality that the developer gets access to is quite limited. These are the APIs, the way these are normally exposed is largely about SIM lifecycle, turning things on and off, messaging, getting involved in the SMS flow, looking at diagnostics, finding new ways to charge and make money out of the traffic. Nothing really particularly innovative, nothing on the same scale, at the same level of flexibility that you get on cloud. So what we're trying to do is a totally different approach. So we're trying to build it's a big dream, build a programmable mobile network. So a mobile network which is designed with the developer as a first-class citizen, to think about, as a developer, what functionality do you need to deliver your solutions to resolve some of the challenges and the issues that are there at the moment, rather than being constrained by the typical mobile network architecture. So we're trying to apply sort of CPaaS principles and C+ techniques to the mobile core network, designing a network as a platform rather than network as a service, with a view to democratizing control, configuration, observability, etc., in the same way as you get on cloud. At the same time, we need to make sure that what we build complies with these interoperability requirements so it can still talk to the rest of the planet. We need to protect the network from bad actors and disruption, and we need to be mindful of what fraud opportunities this could open up that we need to mitigate against. So why might we want to do this? You know, as a developer, what could you do in this way which you can't do today? Well, security is first on the list, you know, for good reason. Security, particularly in IoT, has become a real hot potato at the moment, a real hot topic, and the need to be able to tie down device behaviour and connectivity in a very precise, configurable way has become really, really important. So this allows the developer to be very, very tight over what hosts those devices can talk to in what circumstances, you know, spot anomalies, spot things which are unusual. Manageability, to be able to take, if you've got lots of IoT devices at the top of lampposts, it's very difficult to change the configuration on those devices. You can bring some of that intelligence into the network, means it's a lot easier and a lot much more straightforward to integrate with. Observability, watching what the devices are doing, spot roaming behaviour, mobility, spot what traffic's being passed around, mirror traffic to AI-based platforms for spotting traffic anomalies and security. Getting involved in the roaming process, as it's steering, as it's called in the mobile space, being able to make real-time decisions embedded in the application which controls how devices move between networks. Geofencing, spotting when devices change between different technologies. Again, this opens all this up. And being allowed to integrate with devices and manage them as if they were on your network rather than scattered around the world. Make the integration seamless rather than very complex processes that often is at the moment. Agility, being able to make changes at 2 o'clock in the morning while you're halfway through that pizza, really, really, really useful if you can do that. Being able to spin up multiple different environments, a different part of the software lifecycle, that's something which developers are used to and rely on it elsewhere in their technology. Being able to make decisions about the way traffic is routed depending on where the devices are, from a performance perspective, from a regulatory perspective, security-wise. Software SD-WAN style configuration over mobile data. And monetization, you know, charging for the use of these devices in ways which are better aligned with the vertical that they're in. We're using, you know, crypto-based charging by being able to inspect and control the way the data is passed around. And finally, the basic one, life cycle, being able to see what devices are enabled when, turn them on and off in real time. I could produce another 3 or 4 slides just with these points. The point is that there's lots of different, by getting control under the hood of the mobile network, there's a lot more we can do as developers than we're used to at the moment. So, at Stacuity, that's what we're building. We're building the programmable mobile network. So how are we building it? And this is a bit of a work in progress. You know, this is a project we're probably about halfway through at the moment. So we're not trying to sell anything here. I'm just explaining where we're on our journey. Some of these things might change as we discover more. But what we've started with is thinking about, as a developer, how do you want to interact with the tools and platforms that you rely on? And it's not about diameter signaling and SS7, and it's not about all those telco-specific protocols that the mobile industry operates on. It's about, you know, RESTful APIs, GraphQL, webhooks, WebSockets, WebAssembly, all these sorts of technology and tools that we're used to using in the cloud. You know, we want to recognize the development processes that developers use these days. You know, DevOps, continuous integration, all these sort of things that we're used to, which don't really work well in mobile. And we're going to try and make sure that developers can use the tools they're using today for their general purpose development and apply that to the mobile core. Essentially insulate us as developers away from the esoteric telco technology which happens under the hood. So if that's one bookend, if you like, the other bookend is at the back end. Obviously, when we talk to the rest of the world, we do have to adhere to all those standards and comply with all, use all those protocols. So we've built out the telco protocol stacks, the way that operators talk to other operators, you know, from the ground up, you know, in using modern tools and technologies. So we're not dependent on any third parties for that. Wraps up all diameter SS7, all the protocols that are used there, GTP. And by making sure that that's standards compliant, it means as we engage with operators to use their roaming agreements to get coverage and to globalise this proposition, there's nothing really special required from them. It's just a standard full MVNO model, as it's called in the mobile space. And in the middle, if you like, the gem in the sandwich is we internally, as we're building this out, we're developers as well. We've all worked in operators, so we know we've seen the good and the bad. But we also want to make sure that our development cadence is quick. We can deploy quickly. There's not huge effort involved in rollouts and upgrades. So we're making sure that our technology in the middle is reliant on, containerized deployments, the partitioning and sharding around the data, an integrated data model. So we've, rather than taking a standard mobile architecture that we saw in the previous slides, we've thrown that out the window largely and built it just to use normal IT techniques and development techniques. I won't go through this in detail, but these are just a taste of some of the technologies that we're adopting in the middle. So, Kafka, Timescale DB, Postgres, Mongo, Elasticsearch, it's all the stuff that most techies love in the cloud space. There's two fundamental bits of technology which are really critical, which we've completed now, which is like what we call our interworking platform, which is like the translation between telco protocols and HTTP2 style protocols internally. If you know anything about 5G is based around some of those technologies too. And a very innovative packet forwarding engine, which effectively is a router, which allows programmable control over what packets flow where for what devices. And that's built using DPDK, Rust, AFXDP, again, modern and very performant sets of tools. So, where are we up to so far? So, those interworking stacks for signaling are complete, they're working, they're deployed. That's allowed us to effectively prove the end-to-end mobility and detach process of SIMs. So we produce SIMs which will now attach anywhere in the world, and as those SIMs attach and pass data, generate all the traffic up that the developers will then be able to consume and interact with. Our packet forwarding engine, the Rust platform, the router, is built and tested. We've got our first sponsor operator on board and integrated, so that gives us coverage over 650 networks worldwide for these SIMs. And we've successfully had signed off the end-to-end interop testing of all our signaling. So the bottom layer of that stack on the diagram before is complete, proven and tested, and now we're working on a bit in the middle. So the next steps, so we expect to get the full platform to MVP stage in Q2 next year. We want to now engage with developers, we want to engage with people who have needs in this space, to understand what those needs are and how we can best serve them. To identify some early adopters, some pilot projects, maybe get involved in some TAD stuff, just to try and get a little bit more engagement with the community. Our DevRel platform and the process for that, we really want to get going, because we want to be seen as a developer first business. I mentioned before about Twilio doing a great job of that in terms of documentation and training. We want to do that for the mobile core. We need to roll out the production platform from a scalability perspective. We aim to launch early Q3 next year. We'll be launching a beta program before then for anyone who's brave enough to give it a go. But that's when we expect to be robust and ready for production applications. And we're also in parallel with that onboarding more operators to give us more coverage in different regions and different markets. So we're a small company, so 4 of us here, we're half the team effectively, come here today. We haven't got a brand, so that's why we're trying to be branded. Please track us down, talk to us. We're all techies except Tim, who's the marketing guy, but we let him come anyway. We're really keen to talk to developers to understand the needs and to get feedback. The proposition is still at the shape that it can be shaped. We want to take feedback. We want to gather other people's experiences too about pain points so we can resolve them. Mobile operators, we're talking to many mobile operators who see this as an opportunity to recover some margin in an increasingly competitive space, deploy something alongside their existing core, which isn't disruptive to their business as usual stuff. So there's definitely a win-win there. IoT aggregators and resellers of connectivity who are at times struggling to stay relevant because they haven't got differentiators. We'll talk to those guys too. Or if you're just curious to see how we get on and what we get right and what we get wrong, whether we keep our houses, then I'd like to chat to you too. So that's it. Thanks for listening.
Thank
Any
you.
questions now? We'll have to.